Time for some project description. So this page I'm looking at is on the website, and it is entitled Sample Project, so that you can click on it and see exactly what your project should look like. Of course, your project will have all different numbers, different formulas, and different pictures, but the outline will be exactly the same. This is very set in stone. If you also look at the grading rubric, it has points for every single point on the outline, so everybody's project will be very, very similar. They'll have all the same things. Each outline point has its own separate grade, so you have to do all the stuff on there. It's not as free as other papers or projects might be. Anyway, so here's my first page, and you should have this as your first page too. The cover page is basically step 0 that you've already turned in, but everybody will have some, or a lot of people will have some alterations to their step 0. I've sent the emails out, and they sometimes change a little bit here or there, so that now when you turn in your actual final project, it should have the full outline on the first page up to date. So there's my 4 formulas. So let's look at the actual project. So step 1 says illustrate 2 structures. So when I say illustrate, I really actually do mean draw some pictures or write out a bunch of symbols. For mine, I'm illustrating a sub 3 equals 5 and a sub 4 equals 15. And I've told you each individually in emails which ones that you should be illustrating. My 2 structures, if you look back at the outline, were inserting pairs of parentheses, and for n equals 3, that would be 3 pairs of parentheses in a string of n plus 1 letters. So my string of n plus 1 letters is A, B, C, D, and in each of these examples I've put in pairs of parentheses. So the pairs of parentheses have to according to the structure, had to be matched up. So it's a parenthesization, as if you were looking at multiplying A, B, and C, and D, and you needed to know which order to do it in, as if it was some kind of non-associative operation. So you could put the parentheses around A, B, and C, D, and then there's a pair of parentheses around the whole thing. That's the third one. Or you could put it around A, B first, and then around A, B, and C, and then around A, B, C, and D. And it turned out that there are 1, 2, 3, 4, 5 ways to do that. Now, there's no guesswork here, because you know how many ways there are to do the first structure. And then there's the second structure. For mine, I picked planar binary trees with n plus 1 leaves. And I had to look that up. You can do some Googling to find pictures that other people have drawn. That's perfectly fine, especially if you need to figure out what it means. So in this case, a planar binary tree meant a picture of a tree, which is a graph that has no cycles. Everything is branching like a tree, and it's planar in that it has a root at the bottom, and it's stuck on the page. You can't like pick it up and twist around the branches as if they were made out of wire. It's stuck. And binary meant that every branch point had to branch into 2. So those are the five possible ways to draw a planar binary tree with 4 leaves. Alright, then I had to illustrate both pictures for n equals 4. So for n equals 4, it turned out to be 14 ways to insert the parentheses in a string, and the string this time has 5 letters. And for n equals 4, there turned out to be 14 ways to draw the planar binary tree with 5 leaves. So everybody will have these same points. They'll have 2 values 5 and ooh, haha. I think that's a typo up there. A sub 4 should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, oops. Not 15, 14. Now, I think I've got all the numbers correct on the emails I sent to you, but I messed my own up. So they were n equals 4. They were supposed to be 14. But everybody will have two illustrations of the number of items for the first value of n that I assigned for you, and 2 illustrations of the same number of items each for the second value of n that I assigned you.